Alrighty then, corn children. Children of the corn, it is a fine day for mathematics. And we're going to do a quick review of factoring. This should not be the first time you've seen this. So let's talk. First of all, do you know what a factor means? Do ya? Do ya? Let's just take a number here. Hey, here's the number 6. One can say that 2 and 3 are factors of 6. Please notice that if you have factored something, you have multiplication between the parts. In other words, 5 plus 1, not factored. No. You're looking for multiplication. Yeah, so that's the goal when we say factoring. All right, so let's look at a type of factoring. We call this GCF factoring, greatest common factor. Here's your word you want to key in on. Common. When you're looking for a GCF, and you should start by looking for a GCF, you want to ask yourself, what do all the terms have in common? Check it out. Here's an example. Yeah. Now, there's a minus in between here, so that is going to separate the front term from the back term. This is two terms, a binomial, if you will, and we want to ask, what do these have in common? Well, you can divide 6 by 2, and you can divide 2 by 2. They have that in common. Also, both terms have an x. I have x's. I do too. So I would say, if I were me, that the GCF is 2x. Now, I have written it down. Yeah, I did. And I am going to factor it out. Factoring out is dividing out. So here's the idea. If you have 6 and you divide out a 2, you'd be left with a 3. X to the third means x multiplied together. If you take one of those and divide it out, that would leave 2 of them. Remember the rules on exponents? When you divide 3, divide out a 1, the exponents subtract, don't they? All right. Next we have negative 2. What is negative 2? Divide out this 2, the GCF? Why, that would be a negative 1. We had an x. We took it out. There are no x's left. Yes. And look what we have. Look what we have. We went from a minus in the middle. If you want, I can put parentheses here, to two things multiplied together. It is factored. Yeah, that was a greatest common factor. Now this next example, also going to look for a GCF, but it's so scary. Remain calm. All right, hold on. Let me move it up. What? This is so different. No, it's not. Do you see this plus right here? It separates the front term from the back term, just like our last example. Yeah. And now I ask myself, what do the front and the back have in common? Wow, there's a lot of 3x minus 7s in this problem. I know, right? This has 3x minus 7, it's actually squared, and this has 3x minus 7. The greatest common factor is 3x minus 7. So here's what we're going to do. We're going to factor out, it's like distributing but backwards, 3x minus 7. Now because it is two terms in and of itself, it needs a little parentheses. All right, here we go. From this front term, we have 3x minus 7 times another one. If I take one of them out, 1 would be left behind. It is to the first power. You don't have to write the 1 though. All right. Now there's plus 4, 3x minus 7. If you take the 3x minus 7 out, the plus 4 would be left behind. If you want to double check your work, if you want to check the work, picture distributing this back in and see if you go up in the problem rather than down. I know, right? All right, so let's look here. Inside this big set of parentheses, we can simplify this. These parentheses, because it's a 1 here, are not needed. So I can pretend they're gone, and I can combine the negative 7 and the 4. Yes, I can. Ready? Now, don't throw that away. Here it is. Bring it down. Bring it down now. Bring it down. Inside the big parentheses, there they are, we have a 3x, and -7 plus 4 is -3. Do you see what I see? It doesn't always happen, but inside these parentheses, I believe there is another greatest common factor. You can divide this term by 3 and this term by 3. I know, right? So let's keep going. We want to factor completely. Here's the 3x minus 7. Now, I'm going to factor a 3 out of this. You could put it here, but when you multiply, the order doesn't matter. And tradition says if you're taking out just a number, we're going to put it all the way out in front. I know that's crazy. There's the 3 that I'm going to take out of those. All right, what would be left behind? If you have 3x and you divide out this 3, you would have a 1x left behind. If you have a -3 and you divide out the 3, it would leave a -1. And this is factored, completely factored. I know. Is that the only kind of factoring, though? Greatest common factors? No, there are other types of factoring. Come along, it'll be fun. All the cool kids are doing it. Here's another problem. Now in this one, the directions are still factor. I have 1, 2, 3 terms. It's a trinomial. And I would like you to notice that they do not have anything in common, not all 3 of them. If you're looking for a greatest common factor, it's for all the terms. There's nothing that can be factored out of all 3 of these. So this is a different kind of factoring. Okay, some of you may have learned this using the diamond box method. I know. And it's a diamond if you connect all the sides, but I'm too lazy to do that. So this is diamond box method. There are other methods, but this one will work. And if you have no idea what you're doing, do this. Okay, so here's how we set this up. There is some memorization. In the diamond, we need to do the following. We are going to take the highest powered term and the constant term and multiply them together. If I multiply these together, watch the sign, there's a negative here, this would make -24x squared. That's how you start. The middle term, look at the sign, it's positive, goes here. All right, now if you remember the way the diamonds work, there's a game. We are supposed to figure out the things on the sides that when we multiply, I'm going to put a little dot for multiply. When we multiply, they make the top. But when we add, they make the bottom. Well, how are we supposed to do that? And here's where some of you fall down. Oh, it's a horrible falling down mess. I'm going to list the factors of -24. All right, now let's be clear. It's negative. That means one of the numbers will be positive and one of the numbers will be negative. All right, so what numbers make 24? Well, 1 times 24. Now, I'm not going to list negative, positive, positive, negative, but I'm going to remember that 1 is negative and 1 is positive, okay? Doesn't matter which one, though. All right, 1 times 24. After I try 1, which always works, I would see if 2 goes into 24. It does. 2 and 12. After I do 1 and 2, I would see, does 3 divide into 24? Well, how do you mean? You can check it on your calculator. Do 24 divided by 3. Do you get a whole number? It's on the list. 3 and 8. Then I would check 4. 4 and 6. Then I would check 5. 5 does not work, and 6 is on the list. Once you get to the other side of the list, you have your factors. All right, so here's my list. If you're not able to factor these, it's because you're not writing down the list. You're just trying to think up stuff. All right, now, 1 is positive, 1 is negative. Doesn't matter. It could be the first one's positive or the second one's positive. Doesn't matter. I need to figure out which ones would make a positive 2 when I add. Here's what I see. One is positive, one is negative, and now these will add up to positive 2. Winner, winner, chicken dinner. So I'm going to take negative 4 and 6 and put them here. Now wait for it. If I want them to add to a 2x, they would each need to have an x, and if I multiply, an x times another x is x squared. Okay, that's the diamond part. That's the diamond part. Now what about over here? Well, this is where we actually get the answers. The answers are going to be on the box. Here's how you set this up. There's some memorizing involved. You go back to the original problem. You put the front term, the highest powered term, in one corner. You put the constant term in the other corner. Do you remember this negative 4 and this 6x, or negative 4x and 6x that we worked so hard to find? They go in these. Doesn't matter which one. Now the hardest part is to start these. We need to put on the outside the correct things that multiply to make the inside. So the only way to get a 3 is a 1 times a 3. But the question is it the 1 here or is it the 1 here? How do you know? Well, you remember minutes ago we did a lesson on greatest common factors? That's what we look for. If I go horizontally, if I look at these two, in other words, I'm not looking at the bottom, do they have anything in common? Yes, you could divide both of those numbers by 3, and they both have an x. 3x, the GCF, is what goes out here. What? Yes, I know. Now, once you get started, it's not so bad. These outside things need to multiply to make the inside. So I'm asking myself, what times 3x makes 3x squared? That would be a 1x. All right. Now, look at another box. Doesn't matter which one. I'll pick this one. What times 1x would make negative 4x? Negative 4. Oh, okay. Pick another box. Doesn't matter. I'll pick this one. I have a 3x here. What times 3x makes 6x? Positive 2. So how did this help? These are the factors. This trinomial will factor into 3x minus 4 and x plus 2. Now, you may need to watch that over again. If you need questions or help, let me know. All right, good luck.